Hello, everybody. Greetings from the study center of the Institute of Aegean Studies in Pachiamos in Eastern Crete. I am in very good company here. I'm very pleased. Professor Phil Betancourt is here. Tom Brogan is going to come, and also Susan Ferenc is here. So we are in very good company. And I think we will have a fantastic time today. I'm trying to find the light and sorry. Okay. This is it. I think we shouldn't waste much time. I think the best thing to do is presenting Sofia Nastorskale, whom everybody knows actually. She is one of the pioneers, if not the pioneer, together with Noel Gale, of isotopes in general. And she will talk about Sardinia, a European metal trade junction in the 2nd millennium BC. There is a phone. I'll give the word to Sofia, and I think, thank you. I mute myself here because there is a bit of noise. Sofia, is your turn. Thank you.
Hello, thank you very much. I sent my presentation, so I think they should appear on from Sardinia, my presentation. If there is a problem, I need to get it on my screen. Do we know what's going to happen? Or should I get my presentation on the screen anyway? Perhaps. Well,
if you can begin by yourself, it is better.
Yes, exactly. Maybe.
And be careful in the full screen, because all participants have the small screen. So
small screen. Okay.
No. Have the big screen.
Big screen. Okay. I have it on the big screen, but I'm afraid I have to find it, because I was expecting to be sort of guided from your. From the organizers. As I say, I sent my presentation as expected, PowerPoint presentation. Where do I find it? I'm very sorry for this delay, because I have to find the PowerPoint. I had the okay. This is, let's see if this is the.
We have time until 6. So don't get nervous. We are waiting. There is no problem. In the meantime, I can say hello to all other friends. Ignacio, I already said hello to Fulvia, of course, and Mauro. Hi, Mauro. Oh, I think it's working now.
And then just I have to. Can you see the, what can you see? Can you see the,
just can see the PowerPoint?
Sorry? It is the PowerPoint. Can you see just the screen, or yeah, you don't see the next slides. Okay. Yeah, that's fine. So, hello everyone. Sardinia is our topic today, and we heard in the morning a lot about the contacts which archaeologically are quite obvious with the Eastern Mediterranean. Unfortunately, we didn't hear much about connections with Sardinia, with Spain, because we didn't have the lectures. But it seems that very likely Sardinia has been very much a hub of activity in the 2nd millennium BC, particularly in the second part of the 2nd millennium BC. And a lot of guests and visitors were passing through from the east, from the west, and from the north and maybe even from the south. So I'm going to talk about the evidence of a possibility of Sardinia being a source of metals. This is where the visitors would be coming in to trade metals from Sardinia. So is there any evidence, isotopical, because of course this is what I am going to talk about, that this is a possibility? Now, as Gilberto Artioli said very rightly at the end of the session in the morning, Sardinia is not known to geologists, mineral explorers, and so on, as a island of copper. Is the largest ore deposits are that of lead and silver, and they were very extensively exploited, for example, in Roman times and later. This is why my next slide, which you can see here, doesn't mention copper mines. I specifically said Sardinia mines with copper minerals, because this is what the geological literature shows. So the main mineral deposits are in the southwest, in Iglesiente. Then there are some in the east, and there is Calabona mine and several others in the north, which we visited in 1984, thanks to Fulvia with Noel and Fulvia's colleagues, geologists, and it was very, very good trip, which allowed us to publish a large body of lead isotope data for Sardinia. So there are occurrences of copper. Have they been mined or not? There is a long discussion. No one found huge slag heaps, for example, but that's not I wouldn't say that this is necessarily a problem. We believe that Lavrion was exploited for copper in the Bronze Age, and there are no Bronze Age slugs in Lavrion. So this is not a proof of anything. Tin is a bit of a problem because there are some tin occurrences, but so far I don't think anyone could prove quite for sure that this tin was exploited in the Bronze Age. Okay, so sorry, am I doing it or is someone else doing it for me? Oh, okay, thank you very much. So the beautiful part of something which I should have said, sorry, I should have said before. Can we go back to the first slide? You can see here by the colors that geologically, these deposits in the southwest and in the north are of very different ages, geological ages. Here, the ones in the south are Precambrian. They are about 600, 500 to 300 million years old. Similarly, these deposits are of the same age. When here deposits in the north, the pink ones, the Calabona and the ones around them are much younger. They are from Jurassic period, sort of 100 million years, about plus minus 35, say. So they have very different lead isotopic compositions. What it means is that the whole, you cannot talk about Sardinian field of lead isotopes. There is just a whole range and pattern of lead isotopes on Sardinia. The next one, please. Now, the beauty of this age difference is that, can we center it a bit? Thank you very much. The beauty of this is that the old deposits, which are in the southwest, are very old, and such old ores are not very common in Europe. Copper ores in particular, lead ores, there are some more of this age, but not copper ores. So this is the range of this old copper ores, starting, if we talk about this ratios of 208 to 206, which is sort of easy to remember, is between, say, 2.9 to 2.13 about. And this is this range of lead isotope ratios, which I will be concentrating on because these are the main deposits in the Sardinia which could have been exploited. Next one, please. Now, here, just to illustrate that, I'm showing you a map from a publication some few years ago, where the geologists from Lyon produced a map of Europe showing the ages of rocks and ore deposits in Europe by colors. So you can see this dark blue, this is this Precambrian, Precambrian ore, is in the south of Spain. These are just, this I think is not so important. There are no copper ores here really of this age. But there are copper ores of the same age in the Italian Alps, in Trentino Bolzano, Sardinia, as I said, and then in Wadi Araba, in Jordan and Israel. These are the main copper deposits of similar age to this Sardinian main deposit, which we know have been exploited in the Bronze Age. The next one, please. So, looking again at the more detailed isotopic compositions of ores in Sardinia, here I am using different isotopic ratios, purely because these isotopic ratios to 204 lead are showing the age lines, you can call them. These are the blue lines here, the age lines. The deposits, the ores, the minerals from one deposit which was formed at the same time, on this plot along line. So for example, this mine here in Inglesiente, San Giovanni, just mainly lead mine, who has most of the data plots along the line. Here is the famous Fontana Raminosa in the middle, not very well seen, but these are these little circles, half black, half white. And on this plot, one can see that this is the Iglesiente region. This is all ores from Iglesiente plot here. And in the north, Calabona and Calabona is this one, and some others are a completely different place. You can see the error, it's important, the error of analysis, of lead isotope analysis. Lead isotope analysis done by thermal ionization mass spectrometry, as we were doing a long time ago, or nowadays a multi-collector inductively coupled plasma mass spectrometry, ICP-MS, are extremely accurate. So when the analyses are done well, you can really be sure that this point doesn't move very much beyond what this little cross here is showing. The next one, please. So here I'm going back to the ratios to 206, to this other isotopes 206, mainly because, particularly when the data is analyzed by thermal ionization mass spectrometry, which a lot of this ore data was analyzed by this method, you can rely on smaller error of analysis. So this is certainly the error which was achievable, and we kept it at this level for all data. So you can see here that the ores from Trentino are really mostly separate from the Sardinian ores isotopically. Here there is a bit of overlap, but not so much. On this diagram, all Sardinian ores are in gray, but the yellow triangles are the copper ores which were analyzed. So we could sort of be sure that there is some copper in this parts of the diagram. The more problematic when the separation is concerned are the ores from Spain. I have plotted here only ores from the southeast of Iberian Peninsula, from the area of Jaén and along the Guadalquivir River. And as again, there is proof that these ores were exploited in the Bronze Age. And there is a quite considerable similarity, quite considerable overlap, which is not possible really to distinguish in many ways. So I need to emphasize one thing here, that when we do an interpretation of lead isotope data for archaeological artifacts, we do not look just at the lead isotope data. I'm talking only about lead isotope data here, but normally we look at the lead isotope data at chemical composition, which is very important sometimes. Sometimes you can't really say much about differences in chemical composition, but sometimes there are certain elements which are more characteristic for certain ores than in others. For example, as far as I know, and Gilberto can correct me, in Italian Alps, the ores do not contain enough lead to show beyond, say, 0.1, 0.2% in copper. In Spain, the lead ores and copper ores occur quite often, and the same is with Sardinia. So Sardinian artifacts made of copper made from Sardinia or from Spain could contain, for example, some lead. There are some other trace elements which are also important, but trace elemental composition is important. And for me, crucial point is the possibility of estimate of the age of exploitation. If you know that at certain time the ores were not exploited, then certainly we wouldn't expect them to show amongst the metals. And here, perhaps, Fulvia, if I can refer to your comment in the morning, there was some misunderstanding. We definitely have not found amongst the Scandinavian metals any metals matching Sardinian ores from period 1. So I'm talking about 1700 BC. No, definitely not. If there are any metals which could be from Sardinia, they are much later. They are more in the 1300s, say. Anyway, the next one, please. Something which has been highlighted by Ignacio Montero is that there is a serious overlap of lead isotope composition of ores from Sardinia with ores from Wadi Araba. And here I plotted the data from for the ores from Feynan and Timna. And as you can see, the overlap is nearly exact. Now, here, there is this slight problem that the period in the second part of the second millennium BC doesn't seem to be very active. The mines in Wadi Araba and Timna don't seem to be very active. There is most of the production in Feynan has been dated to early Bronze Age, third millennium, fourth millennium, third millennium BC, perhaps beginning of the second, but not the second half, and then later in the Iron Age and so on. And similar situation, as far as I know, is in Timna. But I must say that this is something which we have to think about and take as a possibility that some metals which might seem Sardinian might in fact be from the deposits in Wadi Araba. Next one, please. So just recently I read this paper about tin from Uluburun, and I really like this map in some way. Maybe it's not completely accurate. Again, some of you can comment on the map, but here they accept that tin is on Sardinia and in Tuscany. But if you look at this map, what strikes me is the distance to the sources of tin. We know the Cornish tin was exploited. Recently, I think there is more indication by the team from Mannheim that the Erzgebirge tin might have been exploited after all in the Bronze Age. Tin in Iberia was definitely exploited in the Bronze Age. Here we have Sardinia. And if we look at the Eastern Mediterranean, then it's clear that, well, Taurus is, again, this is the paper which argues actually the tin ingots on Uruburun, some of them, which have high lead, are actually from Taurus mines. This is something which interests me very much because we have published a paper in 99, I think, or 98, where we suggested that. But in Bodrum, I have seen a tin ingot from Uluburun, which inside had lead bars. it was stuffed like a, you know, like a croissant with jam. It was stuffed with lead bars. So with Jamal Pulak, we sampled this lead, and we sampled the tin. In this case was actually pointless to sample because lead would have been penetrating the tin. So we sampled this lead, and these lead bars definitely had isotopic composition of consistent with the lead ores from the Taurus Mountains. So now the question is how much of this sort of cheating was going on? We don't know, but Taurus definitely had some input there. I mean, the people living in the region of Taurus Mountains had some input. But there is looking at this map, one could see that particularly towards the end of the second millennium BC, sea people problems and so on, when the Eastern Mediterranean, Mycenaean, particularly the Mycenaean Empire at Cyprus, Ugarit perhaps also, when they were short of tin because of lack of contact from these further Asian deposits, they might just as well turn to the Western Mediterranean to look for tin there. And as we know, tin to Sardinia might have been coming from Cornwall, from Brittany, maybe in Massif Central, maybe it was exploited. There's no proof of it, and from Iberia. So the question is, was Sardinia producer of metals, or was it just a middleman? Were they just conveniently placed for everyone to come and get what they needed? The next one, please. So let's look at the copper artifacts from Sardinia, which were analyzed. This is just the whole lot which has been analyzed, about 350 analyses I found in the published. And what is surprising is that, here we have, look, this is Iglesiente mines. Look how many artifacts plot exactly along this line. They are totally consistent with ores. It's mostly copper, but I think there's also some lead here, lead artifacts. There are some other groups of artifacts which seem to be consistent with Sardinian ores. These are oxide ingots. So this is Cyprus. It is beyond the discussion. But there are all sorts of other little groups here which don't seem to fit with any of these ores. So where did this metal come from? I especially put this plot in the ratios to 204. This is this ratio which is least accurate. So this error which is showing here might be in fact much larger for some of these. So I would say particularly that a lot of samples which we have analyzed were from, I would say, third hand, because Noel collected these samples from Stuttgart, from remnants which were left from the SAM project. And some of these samples were very small, very corroded. What was their history, I don't know, might have been contaminated. So some of these, I would say, are just not very accurate. But nevertheless, if I look at the data, then less than 40% could be consistent with Sardinian ores. And the other 60%, no, a lot of them are ingots. And this is definitely a bias in analysis of artifacts from Sardinia, that the majority of analyses are for ingots, not just oxide ingots, but also all sorts of shapes of ingots. And we don't have so many analyses of artifacts, as far as I know. I might be missing something. So this is something which definitely should be taken up and done. Next one, please. So the only thing which one could say about this analysis of ingots, that is useful to see that there are ingots, they are mostly, they're not oxide, they are sort of bun ingots. But as you can see, they plot very well with the Sardinian ores. Unless we say that they are from Wadi Araba, from Israel or Timna, because the ores from Israel and Jordan plot also here. But let's say that they fit exactly with ores from Sardinia. There are some ingots here which might be not quite consistent with Sardinian ores. This one may be more consistent with Spanish ores than with Sardinian, but nevertheless, there are ingots which are made of Sardinian, which seem to be made, which are possible to be made from Sardinian copper. So the copper was exploited, we don't have doubts about it. But how much was it is difficult to say. I must say another thing, that in the Eastern Mediterranean, there is Cyprus, Aegean, for which we have a lot of data. The copper of this Precambrian age, that is copper from, say, Wadi Araba, Timna and Feinan, or from Sardinia, or from the Alps, the Italian Trentino Bolzano, this copper is not visible much. There are few, but is not in great quantity. Even in Ugarit, there is not so much copper from Wadi Araba as one would have expected. Ugarit is mostly Cypriot copper. The next one, please. Next slide, please. Okay, so another new paper, which appeared not so long ago, taking into account the whole of the Mediterranean and the history, Bronze Age history of the Mediterranean, you might say, it shows this very curious map. Here is Sardinia, and they indicate, the authors indicate that Sardinia has pottery and metals which are of the type of the Atlantic Europe and Eastern Mediterranean, but there is hardly any contact with the North. I find it very interesting, something which I think should be further investigated. And I think that our great problem is France. We don't really have, my great problem, don't really have much knowledge about late Bronze Age exploitation of ores in the Massif Central, which isotopically are not very distinctive from many other ores. And we don't have analysis of French artifacts. I found, next slide, please. Next slide, please. I found a paper on the internet, which was given at the conference in France. I was not able to get from the authors any data, but they claim here, as you can see, that copper from Sardinia might have been going to the south of France, which is very interesting, but this is something which needs to be further investigated, particularly with all these possibilities of this copper really being from the Trentino Bolzano. So anyway, this is just introduction to what we know at the moment, and I hope that there will be a good point for discussion with what I said, and I'm now looking forward to what my colleagues have to say about TIM. Thank you very much.
Thank you very much, Sophia, for these very clear explanations. I think you will have several questions. I can't see for the moment any request, but maybe it has, maybe Daniel has something to say.
Alessandra, Giorgio, ministro della regia, dobbiamo far rispettare i tempi, quindi 20 minuti a ciascuno, ok?
Non ho capito.
Mi sente?
La tavola rotonda, la tavola rotonda fa 2 giri.
Fa 2 giri da mattina.
La tavola rotonda fa 2 giri, sì.
Ok.
Prima e poi...
Ok, quindi stiamo nei tempi, comunque sia stiamo nei tempi.
Sì, beh, in questo caso ho pensato, visto che è un'introduzione, ci vuole un po' più di tempo. Ad ogni modo va bene così. Cioè dovrei passare direttamente al prossimo speaker? Sì. So I was asked to pass directly to the next talk because of the time. It's a pity, of course, but we will have a longer discussion at the end. So the next speaker is Daniel Berger, who is now at the Kurt Engelhorn Zentrum für Archäometrie in Mannheim, in Germany, of course. And he is working with isotopes. He has been working with isotopes for a long time. And his PhD was also on this, partly on this topic. So Daniel will be giving a paper again on Sardinia, because we also decided to begin with Sardinia, of course, as we are hosted by Sardinia. The title is Origin and Recycling of Metal for Nuragic Bronzetti, studied with isotopes and trace elements. So Daniel, schön, dass du da bist. Bitte.
Hello. Hello, everybody. Thank you very much, Alessandra, for this kind invitation of myself. And I try to share my screen, so should be visible to everybody now. Okay, so first of all, I have to apologize my co-author Valentina Mata, who should normally or should be here today, but there was an overlapping with her own talk on the EAA conference, which is actually currently also ongoing. So apologizes from her side. Nevertheless, I'm going to present our talk, which is on the origin and mixing. I changed the title a little bit from recycling to mixing, because mixing is a little bit more neutral. The origin and mixing of metal for nuragic bronzetti, studied with isotopes and trace elements. Okay, so I don't have to talk much or say much about that. Sardinia has a flourishing metal industry throughout the prehistory, especially during the late Bronze Age and early Iron Age, dominated by the nuragic culture. And typical nuragic bronze metalwork are bronzetti, which are the topic of our case study. And hundreds of such bronzetti are known from all over Sardinia. They could be anthropomorphic, zoomorphic, or even have the form of boats. And they normally presumed to be locally produced artifacts. What is still not known exactly, not known exactly, is when this is valid for most of the Sardinian metalwork analyzed so far, which copper sources have been used in this time, and which tin sources have been used for the production of the bronze metalwork. So as Sophia showed in her talk, there have been several suggestions of possible origins for the copper, amongst others Cypriot ores, Iberian ores from the Iberian Peninsula, the Sinai and the Red Sea region, and also the use of local copper deposits, but also the use of local tin ores. Our case study included in total 48 samples of anthropomorphic bronzetti from 3 different nuragic sanctuaries and 1 unknown location. The sanctuaries are those of Abinitetti, Sumonte Soradile, and Santa Vittoria Seri. Unfortunately, the dating of the bronzes or the bronzetti are rather insecure due to insufficient documentation during the excavations. And there is, to my knowledge, a tendency towards late Bronze Age dating of the bronzetti. So what did we do with the bronzes? We carried out metallographic analysis, chemical analysis with EDXRF and QICP-MS, and also isotope analysis, which involved the isotope composition of lead, tin, copper, and also osmium. Our research questions were quite trivial, so to say. We wanted to know where the copper for the bronzetti came from, where the tin especially came from. if there have been some, if there have a local exploitation for the bronzes, or if there have been an influx from outside the island. We wanted to understand if there have been some kind of source mixing or even recycling of metal. And this all should shed light on the production practices in Sardinia, the trading networks, and also the role of Sardinia during that time. What you can see in this slide, on this diagram, is that all the bronzes that we analyze in our study are composed of copper tin alloys with tin contents up to 14 mass per cent. They also contain appreciable amounts of lead, often below 1 mass per cent. So in this case, I think that we are here dealing with no intentional addition of the lead, but in some cases, as you can see here, especially in case of the bronzes of Montero, we have partly higher amounts of lead, up to 5, 4, and 12%. So in this situation, or in this cases, we have also considered a intentional alloying of lead to the copper. In general, we are dealing with low impurity copper with low concentrations of nickel and silver, also low concentrations of arsenic and antimony. And this is usually a quite good indication for the use of sulfidic ores like chalcopyrite, or also oxidic ores like malachite and chrysocolla. When it comes to the question of provenance, of course, the light isotope composition or light isotope analysis is the medium or the method of choice. And in this diagram, we can see the lead isotope composition of the bronzes, of the bronzetti, which are contrasted with the most potential ore sources in the Mediterranean area. And what we see here is that the Cypriot ores show no match with our bronzes. This is also valid for the oxide ingots that have been found on the Sardinian island, which are mainly produced from Cypriot ores, and we can conclude, of course, from this observation that Cypriot ores, copper ores, and also the oxide ingots were most likely not the source for the bronzetti. Here I plotted some of the metalwork, other Bronze Age metalwork from Sardinia into the diagram, and we see that we are, in fact, and this also was shown by Sophia in her talk, that we are dealing with a couple of different sources which were used for the production of the bronzes. Most of them are more or less different from our bronzes, but some show also coincidences. So in this case, we also have to think of the use of the same sources or the same metals. When we have a closer look on this diagram, there is a striking trend in our bronzes, in the lead isotopes of our bronzes, which is completely against the trend of the ores and of lead isotopes in the ores, especially evident for the bronzes from Santa Vittoria. And this is, in my eyes, a very good indication that we are here dealing with some kind of mixing. So this trend can probably or most likely be perceived as some kind of a mixing line. And also in the case of the Montero bronzes, we see some kind of trend, some kind of mixing line, which is different from that of the Santa Vittoria bronzes, but in one point they are intercepting. As I said, this is most likely an indication of source mixing. On the one hand, a mixing of copper with lead, as in the case of Montero bronzes, because of their high contents of lead, but also the mixing of different coppers or leaded coppers. If you're in fact dealing with a mixing, source mixing, these areas shown in this diagram or highlighted in this diagram can be perceived as potential members of the mixing lines. And in this case, they could correspond to the original sources, so we have a chance to conclude on the original sources. That there was, in fact, some kind of source mixing becomes also evident from the trace elements, the chemical composition, and the lead isotope composition. When compared with each other, we see here a very good correlation between the lead isotope composition and the nickel and silver concentration, arsenic and antimony concentration, also the indium concentration. So this, in my eyes, is a very good indication for the mixing of different coppers. What we cannot exclude completely is different or a mixing of leaded copper with copper or so on. Okay, so what about the origin of the copper? And first, I want to have a look on the Sardinian island itself. And we have seen the talk of Sophia. There are a couple of ore sources or occurrences, copper occurrences that could have been exploited in antiquity. They are distributed across different regions, and these regions are more or less well distinguishable by their lead isotope composition, and especially in the case of this end member of the mixing line I showed before, we find a very good match with the copper ores from, or the copper mineralization of the Sardinia mine in the Ecclescentic region. We don't find it also not only in this diagram but also in the other isotope ratios. So this is a very good and a very clear indication that here local ores from the Sardinia were mined, were used and distributed over the island to produce the bronzes. In the other case here, the other end member, which involves or includes the bronzes from Sumonte, it is less clear where the ore sources came from. It is probably, or there's very good match with a local lead ores from the region of Prano e Sanguini, also not in this diagram, but also the other lead isotopes. So probably here, in the case of the Sumonte bronzes, lead from this region was intentionally alloyed to the copper, and this copper was then probably mixed with another ore or another copper source. The other, or the third end member down here, we see with this end member that there is hardly any match with the Sardinian ores, but in the next diagram we see there's very good match with the ores, with the copper ores, lead ores from southern Iberia, especially from South Portuguese zone and the Central Iberian zone. This is also not possible at the moment to pinpoint the exact location because of data overlap, but in my eyes there's some likelihood that we are here are dealing with the import of copper, which have been brought to Sardinia and finally mixed with our with local ore to produce the bronzes, especially from the Santa Vittoria sanctuary. What about the tin in the bronzes? And to answer this question, or trying to answer this question, we also analyzed the tin isotope composition of the bronzes, which is shown here in this diagram, contrasted with the lead isotope composition. And very evident from this diagram, there's no correlation between the lead isotope composition and the tin isotope composition, in contrast to the very good correlation or the trend, the mixing lines here in the lead isotopes. And there's also no correlation in the copper isotopes and the tin isotope composition. So most likely from this observation, we can conclude that here no bronzes or no sources of bronzes have been mixed, and no bronzes have been mixed, but the tin was introduced in separate melting steps or production steps for each single object. What about the origin of the tin? So we heard before that on the Sardinian island there are also occurrences of tin in the epicenter region at Pertucara and Canale Serci. These are very small tin mineralization, and according to different scholars, these primary tin mineralization were not exploitable in ancient times. And this is actually also the impression that we get from the tin isotope composition in the bronzes when we compare it with the tin isotope composition of the Sardinian ores and also the ores of Montero and Tuscany. We see there's no match with the in the tin isotope composition of the bronzes with the tin ores. So on base of this observation, we most likely can exclude Sardinian tin sources as sources or as tin sources for the bronzes, for our bronzetti. So it means that the tin must have been imported from outside. Interestingly, we also come to the same conclusion with some tin objects from Southeast Forest, which show also no match with the Sardinian ores and also not with the Tuscan ores. So, but when not the Sardinian ores have been used, which tin ores come into consideration, and this actually a question that we cannot answer or definitely answer by means of tin isotope composition because of the heavy data overlap in the different tin deposits throughout Eurasia. We see here the isotope composition in the tin deposits from Cornwall, France, Portugal, Spain, and the Erzgebirge, and all have overlapping isotope compositions. But in some cases, we can exclude some small occurrences or some regions or some mines. But in the end, there are too much candidates which come into consideration. So in case of the bronzes, we have really a big problem to pinpoint or to narrow down the origin of the tin. In case of tin objects, the situation is a little bit better because we can also use the lead isotope composition, which will be shown by Gilberto Artioli in his talk. But we can also use the trace element composition of the tin, and one of the most important or most interesting elements in tin objects is indium. And as you can see here in this diagram, I show some objects from Britain and from Israel and also from Iberia, some ores, and we see there's a
15 minutes. Can you perhaps?
Yes, yeah, I think 2 minutes left. 2 minutes. 2 minutes? Okay, so we can here see a very good separation into indium-rich tin and indium-poor tin, and especially the Iberian tin seems to be characterized by a low indium concentration, and also the tin objects from Southeast Forest, the Sardinian tin that we analyzed, have these very low indium concentrations, and probably this could be an indication for the use of Iberian ore. But I have to admit this is only one parameter that is included here. So we need in the end an holistic and a more holistic approach in order to answer the question where the tin really came from. Also, we need much more analysis of tin objects, and what is even more important, we need much more analysis of tin ores, especially trace element composition, and also the lead isotope composition. Okay, so conclusions. Bronzetti, our Bronzetti were most likely or most probably made from a mixture of local and probably Iberian copper. There was a mixing of a copper or leaded copper, but no mixing of bronzes. There's no clear indication for metal recycling because no bronzes were mixed. But I have to say some words of caution because on concluding or regarding the conclusion of the provenance just from lead isotopes, because it is seen in this talk. These lead isotope ratios could a little bit be misleading in case bronzes or different sources have been mixed. Regarding the tin, there was, at least in our case, external tin consumption, and yeah, I think I stop at this point, and thank you for your attention.
Thank you, Daniel, for this presentation. We have 1 minute. If somebody has a question, I don't see any questions. I mean, we can postpone the discussion to the second part of the roundtable, of course. Maybe it is better at this stage. And so I would suggest we pass to the next speaker, who's a very well-known researcher, Ignacio Montero Ruiz, who is at the Institute of History in Madrid. And he has been working in archaeometallurgy since many, many years, and is also responsible for the archaeometallurgical project in the Iberian Peninsula. He also directs the Laboratory of Archaeometry of Materials in Madrid. And in this particular case, he is going to talk about Sardinia again. The title of his talk is A Change of Perspective, Lead Isotopes in Nuragic Metallurgy. Please, Ignacio, the word to you.
Hello.
Hi there.
Okay, just a second to put the, all right. You can see the screen with the presentation. Good afternoon, hello everyone. And I would like to especially thanks to Fulvia and Mauro for inviting me to participate in this festival. I'm going to talk about Sardinia, but in fact, I am an outsider of this area. So we are clear that in future will be more connections between the Iberian Peninsula and Sardinia. But in my talk today, I tried to give an overview, a personal overview about what we know about the Sardinia metallurgy. In fact, we are in the same line than Sofia Stosgale. We start with this paper that was published more than 35 years ago. And in this case, it's important because in this research, they clearly mark two important lines. First, what's the survey of mines and possible smelting and workings in Sardinia. And the second line in this research was metallographic and elemental analysis of planoconvex and oxide ingots and artifacts from Nuragic context. From this year, the research went on, and lead isotopes appear in this research, especially by Noel and Sofia Stosgale. But if we move a few years ago, we can simplify what we know about the Sardinian, especially the Nuragic metallurgy. There was a dual copper consumption model that was based mainly on the results of lead isotopes. And in one side, there was the oxide and the planoconvex ingot, and some planoconvex ingots. that was imported from Cyprus, majority. And the second point of this model was that the local production of metals, this branchetti or the votive swords, etc., that was produced with local copper. But a few years ago, this dual model was questioned because we found new evidence that other regions from Eastern Mediterranean was part of this copper trade. When we studied the Ballao, Fontana Cuberta in Ballao Hoard, we found that probably some of the metals, the ingots and the other metal scraps comes from the Sinai and the Red Sea area. You can see here the yellow dots. Here is the Sardinia isotopic field, and in red the Cyprus isotopic field. And we found that there are a lot of metals that comes from different parts of the Mediterranean and the Near East. But we also detect that some of the copper ingots found in the Nuraghe Rubiu could come from Timna or Feinam in the Sinai area. Sophia told us before that was not evidence of exploitation of these resources at this time, but in 2014 was published a paper with Israel copper ingots with this shape that matches perfectly with this area of the Sinai. And the Nuraghe Rubiu copper ingots that was found also matches in the same area. They are very, very close. But also some of other ingots from Sardinia, Samandra are located in the same area. It's true that some exceptions was found. So this ingot or this that from Israel are far from this part, but all belongs more or less from the isotopic field from Timna or Timna in this case, or Feinam in this case, we show in this part. So the possibility that copper coming from Sinai, I think is real. So if we have this evidence, we also analyze this Osrai ingot that's clearly of this type, no doubt, from Gonesa. And we found that the isotopic signature was located in this area. But this area is an overlapping between Sardinia and Timna Feinam. So my question is, really these Sardinia local copper ores were in use or exploited at this time? So probably part of that is that were in use, but we need more evidence to distinguish these two regions. So how to take a scientific decision about provenance in this case? So first is that we need to use the lead isotopes data, and now there are people developing new statistical procedures to improve the difference between areas. It's not an easy work, but probably could help. It's also important the geochemistry of potential ores in both sides, and of course the elemental analysis of metals. But in this presentation, I want to highlight that we need more archaeological arguments. So we need evidence of use or exploitation of these proposed minerals, probably with mining research, or especially archaeological record related to smelting ores. Well, in this picture, we need to identify the real copper resources. And we have a lot of lead isotope that analysis. And in my database, I compile 467 lead isotopes. But in fact, we have only 326 of mines with copper. So it's important because Sardinia has copper resources, but the location, well, we can see the maps that similar to the Sophia's and Daniel shows before. So there are several areas in the north, in the southwest, and the southeast. But what I want to show you is that Sardinia has copper ores, but they have more lead ores than coppers. Okay, so the island is more important in lead resources than in copper resources. And there are more mines in the south than in the center of the north of the island. So it's important that the location of these mines. And it's also important to know the geochemistry of these ores. So we need to know much better the elements present in the copper when it's smelting, and what part of this could pass to the metal. So it's, in this case, I show only a few examples, and it's interesting for me that the tetrady subgroup is present in several mines in Sardinia, but the tenantite subgroup is less represented than the tetrarite. So it's important to know that there are oxides, oxidic ores, and of course, sulfides. But moving to the archaeological record, what we know about evidence of copper exploitation in Sardinia. Prehistoric mining? The answer is no. We have no evidence. So if we read the William O'Brien's books about prehistoric copper mining in Europe, we found that there are no data. So Johan Lind showed the map with the Fontana Raminosa, but we don't know any prehistoric evidence of exploitation of Fontana Raminosa. Probably was in use, but. And what about the second part of this? The smelting, proof of smelting ores in the island. Very few evidence. So recently a paper was published that questioned some of the earliest evidence in Sokudu, and they conclude that there are no evidence of smelting activity in Sokudu. So one less evidence. But on the other hand, we have this new paper too that found some slags in Montemeana. That Montemeana is in the southwest of the island. It's close to some copper mines. In these copper mines, there are malachite chalcopyrite, so it's a possible resource of copper, but the amount of slags is very, very low. So probably we are dealing with a small scale metallurgy. The chronology, it's around 19 to 1600 BC, calibrated BC. So it's pre-enraging. But what happened in this neuragic metallurgy from the second half of the second millennium BC? I use the information, that was published in the book Archaeometallurgy in Sardinia, published in 2005, and we select some paragraphs to show that it's clear that there are little slags in Sardinia. They mention only a few samples from Foraxinioi and Nurajao. So this is important because we have very few evidence. But if we look in detail to this evidence, well, this is the same in this case. This is the words from Fulvia that there are no slags found, only in minute quantities, and the explanation was that the slags were reworked or was reworked in 19th century, but this is not a strong argument at this moment. Well, Begeman et al. Published in 2001 some lead isotopes from these slags found in central Sardinia, and one comes from Nurajao, that is an nuraghe close to the Fontana Raminosa copper mines, and usually people explain that this is located in the gateway of copper export from Fontana Raminosa. So the question is that these two copper slags are not clearly related with Fontana Raminosa. So if people were smelting copper ores in Nurajao, Niedu, there are ores from a different location, mainly from the southwest of the island. So this is important. The other copper slag was from Gesturi and Nuoro, and again, that is very close to the previous one, and the lead isotope are not related with the Fontana Raminosa. So, and in this case, there's not clear the chronology in the same case before. So, because these slags were recorded in an area, but where the people mentioned that roundabout were many furnaces. So there are surface slags. There are no archaeological context. So we don't know exactly the chronology of these slags. In the gestury. And what happens when Foraxinioi, the third site we mentioned, but it's the same. There are no good archaeological context. The chronological could be to the Iron Age, so in the first millennium. So we have no evidence of smelting ore in the island at this moment, and this is important. But what about pre-nuragic objects? Because at this moment, most of the research was focused in nuragic and in oxide and copper ingots. Well, the case of the swords from San Iroxi and Maracalagonis is strange because they did lead isotope from 3 samples from the same object, and they obtained different values, so was not accurate at this moment, this information. And the Maracalagonis swords, they comment that they're internally inconsistent. So we have no information, useful information in this case. We did in our project with Fulvia and Maria Rosaria a few pre-nuragic objects analysis. One is from Bao Sumatutsu, the second is the halberd from Gonersa Seruxi, and I add a third example from a nuragic type dagger from Saida Horde. Okay. If we look at the results, let me see because I have on the screen, we can see that the dagger from Bao Sumatutsu is located in this central area that it was not easy to distinguish at this moment, because the ores from the southwest, the ores from central Sardinia, or the southeast from Sardinia. So these are located in a non-clear area, but clearly could be local copper. The Gonesa halberd is mainly related to ores from north of the island, and the Saida dagger is also related with these north copper ores. I show you here the copper ingots from Nuragia Rubio that I connect with the Sinai copper ores. So at this moment, we have no evidence, clear evidence of copper use from this southwest of the island. So if we add all the information from Oxalate database and the paper from Begeman et al., we found that obviously the Cyprus is clearly represented with this concentration of data. And we found very few objects that could match with ores from the north of the islands. And we have this area that could be overlapping with the Sinai area. And if we found these copper ingots, and we found that other copper ingots comes from the Eastern Egypt, so I have doubts about the local use of this southwestern copper ores in Sardinia. So, as conclusion, probably Sardinian copper ores were in use in prehistoric times, but we need more archaeological research in order to clarify where and when these local resources were exploited, and to determine the scale of mining and primary metal production in each prehistoric period, because we are dealing about copper trade. So there are two different things, a small scale or a big scale. So the metal trade of copper ingots from Eastern Mediterranean region, some of them with similar isotopic signal to Sardinian ores, makes necessary a more comprehensive and wider research framework. So we need lead isotopes from Perinragic and Iron Age metals to compare the evolution or the changes in this production. We need more slags from secure context to prove that the ores were exploited and used. Of course, an important thing that never mentioned, that we need data from Corsica, because Corsica has copper resources and there are cultural connections between both islands. Well, this was my point of view. Thank you.
Thank you very much, Ignacio. I think we decided to postpone everything, or every discussion, to the second part of the roundtable. And so I would say we pass to the next speaker, Gilberto Artioli, who is a professor of mineralogy, crystallography, and material sciences at the University of Padua. He is also director of the Circe Center of the University of Padua for the investigation of cement, and the chair of the UCR Commission on Crystallography in Art and Cultural Heritage. His title, the title of his presentation is Lead Isotope Ratios Applied to Sardinian tin metal objects. Please, Gilberto,
yes,
it's your turn.
Can you see the screen?
Yes.
Okay, very good. Okay, so I should talk about the Sardinian tin. And if copper and bronze are a problem, I mean, tin is a much more complicated problem because of the tracers we use. I will try to put this into context a little bit. So chemical tracers for tin have been tested several times, but there is no enough systematics and no adequate understanding of their behavior in order to be very effective. As we heard from Daniel, the variation in tin isotopes within a single ore district is comparable or larger than the difference between distant deposits. So they can be useful locally, but it's very difficult to do provenance with that. If we want to use the lead isotopes to trace tin, we must apply it to very pure tin objects, because in general, lead does not enter into the cassiterite lattice, the crystal lattice, whereas uranium and thorium do. So we do have that the cassiterite has much less lead than any other metal like bronze and copper. So we cannot apply it to mixed tin copper. And it is very radiogenic because of the content in the radiogenic elements. So I'm not going to the physics of it, but it's very important to understand that thorium and uranium are acting differently. Thorium goes into 208, whereas uranium goes into 235 and 238, end up with lead 206 and 207. This makes it so that when you plot the cassiterites ore versus the lead isotopes of the other ores, sulfidics, for example, they are very much radiogenic, and if we plot them into with the ratios with 204, the stable lead, they spread out to very high ratios, and they exit from what we normally consider the common lead hypothesis, which means that the lead coming out of the normal reservoirs from the geological content. So this means that many times what we need to do is to understand really the geology of the deposits in order to model the age. And in general, I mean, we do have, I'm cutting and simplifying very much the geology here, but we do have Paleozoic deposits, let's say an age of 300 million years or more. And we do find them, especially for what we are concerned, in the West, what I call the Atlantic province that goes from Cornwall to Galicia, basically. And we have a little bit of other deposits in Central Europe, of course, and Sardinia, Southwest Sardinia is also involved because of the same age. But more in general, I mean, they spread throughout, especially the craton of Asia, and many of the deposits, the Chinese Tajik deposits are also of the same age, which creates a problem. We will see that. And then we have most of the other deposits are involved with the Alpine Himalayan orogeny, and they are much more recent. Let's say from late Mesozoic, Cretaceous up to Cenozoic, roughly 57 million years, give or take 10 million years or so. And this is the map that Sophia showed before, and we can argue with some of the dates, but again, you'll see that most of the deposits around, from Balkans, Anatolia, Iran, and the Himalaya are from the Himalayan Alpine orogeny, whereas the Chinese, Central Asians, and the Atlantic province are much older. So this means that if we model the age with what they are called the isochrons, and let me just correct a little bit Sophia, These are really isochrones. That means that the variation of the ratios with age. Whereas what you showed for Sardinia and what is usually also shown for example, the Aegean are mixing lines, which are geochemically slightly different from what we call the isochrones. If you calculate the isochrones from those, you get ages which are older than the Earth. This is clearly not possible. So those are geochemically mixing lines. But anyway, so we do have a grasp of the model ages for the Paleozoic deposits, and you see that many of what we have, the ores which are analyzed from Cornwall and Iberia, the blue and pale blue dots, fit fairly well with the isochrone we expect. But there are a few which are much higher. They are radiogenic, which means that they got uranium, and as you can see here, also a little bit of thorium in the cassiterite. So there are local variations, and these must be understood a little bit better, I think, where they are. Maybe Alan Williams can comment on that later on, maybe, because we have a better grasp of the Cornwall geology. But anyway, in Iberia we see the same. And very interestingly, there's only one point. I think Sophia analyzed it a long time ago from Afghanistan, which is also extremely enriched in thorium and not in uranium, which is a very unusual one. And this might also be important. I comment that on the paper that you that is referred to, especially for some of the extremely radiogenic bronzes that Lloyd Weeks found in Oman. But anyway, the unfortunate case is that we don't have many analyses of the alpine orogeny in the Asia, like Iran or Anatolia. And the data that we have are very much biased by the Chinese field, which are older than the normal, Mediterranean. So there is an ambiguity, and this creates some problem in the interpretation. One positive thing is that for some reason, most of the cassiterites from Asia are very devoid, apart from the Afghanistan one, but this needs to be confirmed. They are very devoid in thorium. So they actually, on the 208, they really differentiate from the Paleozoic deposits of the Atlantic province. So having said this, if you look at the local deposits in Sardinia, like what we have, it has been mentioned that there are sparse cassiterites, not placers deposits. I think Daniel is perfectly right. But also the Taurus one, and in Anatolia, or the Tuscanian one, Monte Valerio has been mentioned endless time in the archaeological literature. But I'm positive that they've not been exploited in prehistoric times, and I fully agree with Daniel on this. I'm not commenting this, but this shows again the same exact things. I mean, for the Atlantic province and Iberia, there is a neat difference. The radiogenic character of the cassiterite with respect to sulfides, whereas for very different reasons, one is the age, the other one is the lack of uranium. The Sardinian deposits are very similar, to the copper deposits, the sulfuric one. Now, having said this, this is our reference frame to which we need to compare the lead isotope of 10 of the pure objects. I have to mention this, that we have analyzed some of the objects already 5 years ago. And when I presented the first data on a meeting in 2018, and I mentioned that some of the Uluburun objects or the Levantine ingots could come from Cornwall, there was an uproar. So the audience was totally destabilized, and I decided not to publish anything. But fortunately, Daniel published it in 2019, and then we made a review, and now Powell has brought a different interpretation that we can discuss. But the general view now of most of the ingots that or maybe later on Morris Jansen will tell more about this. But the general view that we have now is that all the ingots or tin ingots from the Eastern Mediterranean are from different sources. You can see clearly that they follow this apparent Atlantic trend. And also there is some very radiogenic one, which is also fitting with those outliers that I showed you before, coming from Cornwall and Iberia. So I cannot give you a positive answer, but we certainly can tell that there are different sources of the eastern of the tin that is found in the Eastern Mediterranean ingots, and very likely part of them are certainly coming from the Atlantic province. And we definitely need many more data of the Asian ores in order to understand better the trend of the Asian ores. Now, I'm not going into the interpretation of Powell's that has been interpreting. He partly convincingly shows that where we have a lot of lead, I mean, there is contamination. And he actually corrects for this contamination and argues for an Anatolian origin of part of the ingots. Now, what is the situation from the Western Mediterranean? Now, we do have several objects inland in northern Italy. This is an ingot from Parma. This is a very thin wire from a sort of ore from Alba, and droplets of tin from Alba also. And of course, we do have the two, jugs that Ignacio sampled and sent the samples to us, and also several ingots from Villa Grande Strisile that have been analyzed several times. Now, if we plot these data on the interpretation frame that I showed before, we are exactly in the situation that of the Eastern tin ingots, meaning that just to show you, I mean, these two stars are the two jugs. The orange Bomba, diamonds are the inland from northern Italy, and the yellow are the ingots from Sardinia. And you can see very well that most of the objects lay in a line fitting with the, more or less the isochrone we expect, maybe more the Iberian one than the Cornwall one. Some of them are departing, and they are going in the same direction of some of the Ulburun ingots and the Iberian ores. Some other are totally different, and these are telling us that maybe there are 3 different sources of tin in Iberia, and this is also fitting with what Daniel was saying before. These are some data that Ignacio suggested from a cargo recovered in Iberia, and this is even different. I mean, it means that it has basically no uranium at all, and very deprived of uranium. I start thinking that it might be the origin could be stannite instead of cassiterite, but we can discuss that later. So, what are the conclusions? Sardinian tin is not used. The tin was imported from several sources. Tin from the Atlantic province is very likely, like the Eastern Mediterranean ingots. We definitely need many more data from the Asian ores in order to be able to interpret the data fully. And I thank you very much for your attention.
Thank you, Gilberto. I must say I'm getting more and more confused. Doesn't matter, we will clear up everything in the discussion afterwards, I'm sure. we